Following discussion with some students in our office hour this morning, it's pretty clear to me that we could probably do some review of LINQ itself because students have been using it, but some have had a little bit more experience than others. And you know what? It's not going to hurt to just refresh and talk about the basics, some things that might have just gone by a little quickly in the past as well. So, language integrated query. What is it we're really talking about here, and why would we bother? Well, LINQ allows data selection and manipulation, right? All the things we normally do with SQL, but we can do it right with our C#. Note here, you can also use Visual Basic, but we're not spending a lot of time on Visual Basic in this class, right? Although I do like VB as well. And there are many benefits to using C# to write our queries using this language integrated query approach, as opposed to using just straight SQL. Okay, SQL commands, we know we can put them together. We did a lot of work with that in the past couple terms, right? But basically, when you build it inside of your .NET application, you're working with strings, right? So you put these strings together, sometimes concatenating smaller strings into one larger string for the whole command, and you pass it off to the database, right? Trouble is, strings are very brittle. In other words, it's easily broken, right? If you miss a character, even maybe you need a space between a couple command words as you're concatenating a string together. If you miss that space, the whole thing will just fail to compile in the database, and you'll just get an error at that point in time. But no warning ahead of it, right? There's no syntax checking or validation happening as we actually put the query together in our application itself, right? Another thing is we don't have any IntelliSense to help us write the queries, and they're not strongly typed. Okay, so it's just a string is all it is. So it's really not the best way when we now have this preferable way to do it using LINQ, right? So it allows us to query, and of course, you should be aware that it's more than just database tables, right? We have LINQ to objects, and we'll be using that during the course as well. Any in-memory collection, we can, do a LINQ query, and quite often it's the most efficient way these days to write our code. But there's LINQ to SQL, specifically geared towards SQL Server, LINQ to data sets, XML, even XSD, that goes along with XML, parallel LINQ. Okay, parallel processing if we have in-memory collections we want to, execute a query against in very, very fast format, right? LINQ to entities, which is essentially what we're using here to a certain degree as well. And there's even more. Yes, all the Ginsu knives are here. And they're adding more and more to this list as well. So there's implementations of LINQ to Amazon and expressions and so on and so forth, right? Flickr, you name it, okay? So essentially, what is it when we come down to it? Well, all it really is we've added some new operators. We call them standard query operators, or SQOs, right to our native language that we're programming in our case, C#, right? But note that they're there for VB as well. So, and along with a couple other new language elements that we'll talk about later on, like lambda expressions, it helps us build strongly typed queries in our native language with all the IntelliSense and support that we can possibly get, right? So just to compare, you remember this from term one, right? Probably have nightmares about, this kind of SQL command. Maybe your various clauses, select, from, where, and so on and so forth, right? Remember, group by has to come after order by, or whatever, right? So we have all these clauses. Okay. Doing the same kind of query with LINQ to objects, okay, might look like this. Now the top one is showing VB syntax, the bottom one is showing the syntax for C#. Now the main thing that should stand out to you is the difference in order. The from clause comes first, right? As opposed to with good old standard SQL, the select clause or projection where we define what data will be returned comes first, and then we would say from. Now, odds are you might have been taught earlier, or you might have thought of it on your own. If you just initially put select star or something like that, and then work on the from clause, get the from clause nailed down, then when you go back to maybe fine tune the projection, the select clause, you'll have IntelliSense there in most of the tools we use to help you, because that IntelliSense isn't available until you define what you're selecting from to begin with. So, with that experience behind us, okay, it's not surprising then that the people who developed LINQ realized, you know what, if we do the from first, then we'll have all the IntelliSense and assistant in building the rest of the query as we go along, right? That's the main difference you'll see in terms of how you put the query together. Okay, just a quick example here, with a array of integers, I might do this kind of an expression. From n in numbers, where, right? And then there's an order by, and then we finally say select n. So the select comes at the end, and the from comes at the beginning, right? Okay, we'll get into the details a lot more coming up, but just in terms of the syntax, okay, for the syntax for this, we do need to rely on, besides these standard query operators, two of the, I almost feel embarrassed to say newer, because they've been around now for so many years, but anonymous types. Now, VB always had this, and C# didn't initially, so they added it, right? The idea is we can use something like the var construct so that we don't have to know ahead of time what type we'll be returning from an expression, right? Very important, because with a LINQ, you might not know, what am I going to get when I actually execute this query? Well, we'll be ready for anything with the var construct. Another thing is lambda expressions, okay? These come naturally out of any sort of development situation, because sometimes the information you need to pass to something, whether it's a method or anything else, could be a description of how to evaluate something, right? And so that description of how to evaluate, well, really that is a full function in itself. I like to think, I think an inline function is probably the term here that might ring truest to you, right? And they can be anonymous, they don't have to be, but usually they are, okay? So basically, here's a quick example, right? So this lambda operator, which we have the equal sign and then the greater than sign together. We normally read that aloud, and you've probably heard me saying this before, as goes to. So the left side of the lambda operator defines the input, okay? So this is, if I'm giving you this, do what with it? Well, that's on the right-hand side. That's an expression, and this is describing what will be returned by the lambda itself, right? So as it says here, the lambda expression, x goes to x times x, right? Well, basically that means if I give you something for x, you're going to return x times x. So you can see down below, if we give you 5, you're going to return 25, right? But you're describing a full function, basically. So, by the way, we don't need a delegate. That's not a requirement. This is just showing you have the option of defining a delegate, my delegate here. It equals this whole expression. X goes to x times x, right? And then you could use it like it was a defined function, kind of reminiscent of what you did way back in high school. Yes, if you can remember high school, right? The good old y equals f at x. It's kind of something along that line, defines a function itself, right? So we can pass these lambda expressions, which define a function, to parameters that are looking for the definition of a function, right? Okay. Now there's basically two styles to writing LINQ, okay? And therefore, since we can combine them together, we end up getting 3 different syntaxes. The first one, I know these are new names, right, to worry about having to remember. Don't worry, it won't be on the test, okay? Using them will be on the test, but knowing the names for them, I don't think I'll put that as a question here. So anyway, query expression syntax. Well, that's kind of what we've been showing mostly so far. We have from, right, and so on and so forth, okay? Extension method query syntax, well, that's where you just use your dot extensions, right? And so you can pretty much do any query in either of those two, but sometimes there's a limitation, right? Some things are only available as an extension method. So that's where we get our query dot syntax. So we basically write as much as we can in that initial query expression syntax, which looks quite a bit like SQL. And then we might wrap the whole thing in brackets and put a dot at the end to have an extension method of some sort, something not supported just in the query expression syntax itself, right? So in general, right, query expression syntax is probably easier for you to get onto if you're coming from a background of using SQL, because it looks the most like SQL. But I'm going to be honest with you. Truth is, as you get used to the extension method syntax, you'll probably find yourself just doing that more and more often. Truth is, it always gets in the compiler, it gets converted to extension method syntax before it gets sent off to be actually evaluated, right? So the query expression is really just there for us to help us have something that looks a bit more familiar, right? So the query expression syntax, now this isn't my word, this was from an online resource that I came across. I like how they describe it here though. It's a gentler, a gentle way of describing the extension method here, right? Of writing the LINQ query. So we say things like from the identifier in the source collection, right? Let, where, order by, select, group, okay? So that's the general overall format that's available, right? So the earlier example, and this one again, from n in nums, okay, where n is less than 5, we're going to order by n and then select all the n's, all the values, right? And so that would give us, basically everything that we would need. But note that we could write the exact same query just with extension methods. One of the biggest differences with an extension method, we have to use lambdas, right? We have to use these expressions that describe like a y equals f at x, okay? So notice we get away from lambdas for the most part here in our query expression syntax, but to rewrite it, okay, we just go to our integer array called nums dot where, okay, and our lambda expression is n goes to n is less than 5, right? Order by, now this might look funny, right? N goes to n. Well, that's the way with a lambda. That's what you have to do in order to specify that what we really want to order by is n, right? But it has to be a lambda expression, so we put it in that format, okay? Now just notice that I've broken it out in the top half of the screen here, and we usually do this with each sort of clause of the overall query on separate lines, right? Nums, and then we hit the enter key, go dot where, then we hit enter key, go dot order by, and so on and so forth, right? It can all be on one line, all one big long expression, okay? One of the reasons why we would often spread it out across multiple lines is it does give you a chance, you can comment out an individual line then, or clause, so to speak. So if, maybe you wanted to test run without the where clause, right? Then you could just, in the way it's written in the top half, you could just put 2 slashes to comment out the where and still execute the rest of the query. Okay. So what is this query dot syntax? Well, really, we start off writing in query expression syntax, right? And then we wrap the whole thing in brackets and follow by an extension method, okay? As long as the query expression returns an IEnumerable, it can be followed by a whole chain of extension methods. So for example, there is no distinct operator available, or a way to say distinct, in the query expression syntax itself, right? So if I want to guarantee distinct, in other words, unique values to be returned, right? Then, because notice here in our integer array that we've got like 3 is repeated more than once and things like that, right? So from n in nums, where n is less than 5, order by n, select n. Well, the trouble is we would get 2 results for 3 because they're both less than 5 and would be in the output. But by going dot distinct, now any duplicates will be suppressed and we'll only get 1 value of 3 being returned, okay? So that's just one example because distinct isn't available in query expression. This is how we would combine the 2 syntaxes together in query dot syntax. Just a couple more examples. So here in query expression from C in contacts, okay? Now see, contacts in this case is an actual class, right? So it's an object, unlike the integers we've talked about so far. So notice that we use the dot here where C dot state, that's the property of each contact as we consider them. Are they a candidate to be included in the output? Well, if that compares to WA, in other words, the state is Washington, forgive the American, but that's okay. Order by C dot last name, comma, C dot first name. In other words, we're still referring to this placeholder variable, this C object, right, as we access its different properties, and then finally select C. Okay, so that's how we would write it with query expression. Now the exact same query with extension method syntax, right? Well, we just go to our contacts array dot where, okay, where C dot state, okay, so that's in a lambda now. C goes to C dot state compares to Washington, right? Then we say order by last name, and I mentioned this in our recording the other day. You can have only a single order by extension method, but then you can say as many then bys as you want, right? Okay, so that's an equivalent approach, just using extension methods only, right? Here's another one where we have 2 collections of contact objects and call log objects, right? And we can use syntax like this, from call and call log join, right? So we're doing like an inner join here. Contact in contacts on, what's the relationship? call.number equals contact.phone, right? In other words, we called their phone number. We can do an order by, okay? And then order by when the call was made. And then we can even select into a new object altogether. So that's something I could have showed in the previous syntaxes as well, or examples. But instead of just selecting N or something like that, we can actually generate a brand new anonymous class, right? Now, if it is a class that we've taken time to define, then we would actually specify that this is that type of class. But this is going to make a new a collection of anonymous objects containing first name, last name, when the call was made, and the duration, right? Of course, then we have a dot take 5. Again, something that doesn't work in query expression syntax, so we have to use the brackets and dot, right, in order to do a query dot example. Okay, all right. So doing that exact same one completely with extension methods gets ugly. Okay, it's actually much easier to read this and kind of understand what's going on, I think, than doing it all with extension methods. But I'm just proving the point that you can do it. Now relax. Very rarely are any of our LINQ queries we're going to write going to be nearly as complex looking as what you're seeing on the screen right now. And we'll be building up to it before we ever have to do anything like this. Okay, so a few tips to kind of round out our discussion. Because of your SQL background, you may want to use the query expression syntax for the most part at first. Easier to read and learn, and you can skip those lambda expressions if that's something that you're quite new to and you're not quite used to yet, right? Of course, if you want to mix extension methods with them, okay, then put the extension methods at the end, right? Okay, keeping the query expression each part on separate lines allow you to individually comment out individual clauses for debugging and analysis and so on, right? Okay, an extension method express the most limiting query method first, right? So, technically it would allow you to do an order by before a dot where, right? But you should do the dot where first so you reduce the number of things before you actually get to the dot order by. Now that applies mostly to when we're just linking collections of objects in memory. When you're passing this off to a database, it'll actually be converted into SQL to be executed there, and that's really not quite so important then. One final point that is going to come up in our examples as we're building them inside of our LINQ queries soon, okay, in our controllers, I should say, right? The two syntaxes do not always give the same thing. For example, here, I've got patient, okay, and I want to include the parent object, the doctor, but also there's a many-to-many relationship with the different conditions the patient has had throughout time in their medical history, right? So I got a whole bunch of includes is what it comes down to here, right? So doing extension method syntax, I go to my db context, .patients, .include, okay, P goes to P.doctor, so in other words, we're including the doctor object, and that will be fully populated, materialized inside the patient. And then we're going to include as well the collection of patient conditions, right? Those are those objects that sit in the middle between patient and condition in a many-to-many relationship. But then we can include the actual condition itself. So then if the condition name or something is a property of that, we can have that data available in our patients collection, the var that we're creating here, right? Okay, that's all good. So this is a fairly more advanced one here with all these extra includes and then include and so on. But my real point of this slide is, what kind of an object is this patient's collection? It is a I-includable queryable of patient, comma, condition, right? Okay, whew. Okay, that's a big fancy name for something, right? Well, that's okay, and if that's all you need it for, you're fine. But one of the really nice things about LINQ, okay, is that if we set up our queries so that they just return a simple iQueryable, then we can define the basic query, and it doesn't get executed till later. So it gives us a chance, right, to maybe add more and more to the query. It's like defining the from clause, okay, and the projection, basically, and then later on saying, well, you know what, I want to add a where clause, or I want to add an order by, and I can customize those as I go along, right? So rewriting the same query in the query expression syntax. So from P in context underscore patients, okay, with my two includes for doctor and patient conditions, and then include condition. I just say select P. You might say, well, that's exactly the same thing. Yes, And it really does return the exact same information, but the difference is it returns a iQueryable of patient, right? And that's what we usually are looking for so that we can easily add additional where and order by clauses before executing the query. Now, if it sounds like I'm talking about rocket science here, I'm not. And you'll quickly see as we start adding filtering and sorting and so on to our index views how useful this approach can be. So I thought I'd mention it here so I can refer back to it later. I don't expect you to grab this concept 100% right now, but it will come clear as we build more examples. All right, well, that's it for my PowerPoint. So I'm going to leave that little discussion available for you to review.